Welcome to our monthly Forge newsletter. This month, we are going to talk about surface boundary conditions. To illustrate its applications, we have chosen two very common cases. First, we will show an example of heat transfer coefficient in quenching tank configuration. The second example shows how to define a specific set of friction on the tooling. First, let's see how to set up a specific heat transfer coefficient on one surface of a part quenched. The example is a simple fuel tank. We define the set on one surface of the tank to simulate the agitation jet of the water tank coming directly through this surface. The jet orientation has an impact on the cooling of the part, and we want to consider the effect of the jet in the simulation. The jet is assumed to double its heat transfer coefficient while directly exposed to the part. Here we see how to copy and paste an existing project to make a new revision. The surface boundary condition set is available through the Advanced tab of the object considered. Here the fuel tank. The user adds a set and specifies the location of set where the conditions will be applied. Once the surface selected, here with a plane, the user picks the specific condition to apply on this set. We consider a local temperature lower than the homogenized quench tank due to the jet at 70°F. In the heat transfer coefficient field, we double the heat transfer condition normally considered for a homogenized quench tank. The specified surface will cool twice as fast as the rest of the part in this example, and assuming a lower local temperature of the water. We now show the temperature evolution for the reference case without local heat transfer coefficient. The cooling is symmetric throughout the part. We now show the temperature evolution for the modified case with local heat transfer coefficient considered on the right-hand side surface. The cooling is no longer symmetric throughout the part. The right surface cools faster than the rest of the part. Here is a closer look at the reference case. We have reset the scale to focus on the final result of the quenching. Using the same scale, we can compare to the modified case, showing a clear heterogeneity due to the effect of the jet on the right-hand surface of the part. The other example we want to show today is the definition of a specific friction zone. This example illustrates how to consider several roughness on the tooling, as well as different spray zones. The case is a simple automotive spindle forging. The reference case uses a traditional water and graphite friction. Here we see how to copy and paste an existing project to make a new revision. The feature is available under Properties, the usual location to apply friction. The option Show Set Definitions enables the users to define their own set of friction on any object. The user specifies the object to apply the set, then select through the set's options, here the painter plane, to define the friction zone. The particular painter plane option used here works by using a seed element and expanding the selection using the tolerance angle between each normal of the surrounding elements. The local normal enables to propagate the selection by including new elements in the initial pool of seed elements. It enables more precise selection. The user picks the friction coefficient appropriate for the specific sprayed zone or specific roughness. Here we do not consider lubrication within the set. We repeat the same operations for the top die using the same tools explained earlier. We show the filling evolution of the billet in the cavity for the reference case. Note the flash area. Here is the filling evolution of the billet for the modified case. Note the flash area in comparison to the reference case. This comparison shows the difference between the reference case on the left-hand side and the modified case on the right-hand side. The modified case, with no lubrication in the flash area, shows a smaller flash area within the free flash zone. The modified case contains the material more efficiently than the reference case. We can also measure the flash evolution. In this section, the flash has been contained more efficiently in the modified case. However, the tonnage has increased for the modified case since it requires more force to push the material in the flash area. The green curve represents the modified case. That is all for today. I hope you have enjoyed this newsletter. Please feel free to contact us if you have any question or comment. You can contact Nicolas Poulain at nicolas.poulain@transvaloramericas.com. You can also find this newsletter as well as all other past newsletters on our website www.transvalorusa.com section newsletters. Thank you for joining the community of our newsletter readers, and we will see you next month for some other exciting videos. Have a nice day.